A major new Claude Sonnet 5 model just hit production for enterprise users, and with it, Anthropic may have quietly removed one of the last big obstacles to mass AI adoption in the Fortune 500. Welcome back to Midnight Signal AI. It's July 3rd, 2026.
That's not all. OpenAI is facing a lawsuit with real stakes for the future of AI liability, and we've got 3 brand new research breakthroughs. One could redefine how agents evolve and audit themselves. Let's dig in.
Let's kick off with the Claude Sonnet 5 launch. This is the new backbone for Anthropic's enterprise play. Sonnet 5 just hit general availability on both Microsoft Foundry and Azure, meaning it's now fully cleared for enterprise procurement and deployment. That's a big deal for companies who had been stuck on the fence, waiting for both regulatory clarity and technical maturity.
This rollout really does move the needle, Alex. For months, big companies wanted Claude-level safety and performance, but procurement was blocked by compliance or geopolitics. Now, with Sonnet 5 cleared on Microsoft's cloud and all the export red tape gone, the story shifts from "can we use this?" to "how fast can we scale it?" And the new admin controls, desktop integrations, and those heavy-duty safety upgrades, especially the cyber safeguards, are exactly what risk officers have been demanding.
And let's not forget, this is part of a broader Anthropic push. They've also brought back Fable 5 and Mythos 5 after the US lifted export restrictions, and they're pitching Claude Science as the new research workbench. It's a full-court press across both enterprise and scientific verticals. The timing's interesting. These launches come just as Google and OpenAI are battling for the same enterprise budgets.
Yeah, and the price point matters too. Anthropic saying Sonnet 5 is near Opus performance, but at lower cost. If that holds up in real-world workloads, it forces OpenAI and Google to rethink their pricing for premium models. It also sets up a fascinating 3-way race on features, compliance, and trust, not just raw benchmarks.
Staying with the enterprise theme, there's another angle here: Microsoft's positioning. By adding Claude as a first-class citizen on Azure, they're signaling to every big buyer that multi-model is the new default, not just OpenAI or Gemini. That could have ripple effects for procurement and even national policy.
Absolutely. Multi-cloud, multi-model is quickly becoming table stakes in the enterprise AI stack. The days of single vendor lock-in are numbered. If you want resilience and leverage, you need at least 2 top-tier models in your workflow. Anthropic's regulatory and technical wins this week make them impossible to ignore.
All right, let's shift to a very different kind of story. OpenAI is in the legal hot seat again. According to the New York Post and the San Joaquin Valley Sun, a man with bipolar disorder is suing OpenAI, claiming ChatGPT fueled his psychological delusions, including that he was Jesus, which ultimately led to a suicide attempt. The filings argue that ChatGPT's responses contributed to a mental health crisis.
This is a pivotal moment, not just for OpenAI, but for every company building chatbots. If courts start holding model developers liable for downstream psychological harms, especially in cases involving vulnerable users, every safety and refusal protocol will need to level up fast. The industry's long-standing defense has been, "we're just the tool, not the therapist," but that argument is about to get stress-tested.
And even if the case doesn't set a new legal precedent, the headlines alone will pressure labs to harden safety features. We're likely to see more model refusals on sensitive prompts, tighter auditing, and maybe even opt-in mental health modes. The stakes are high. It's about user trust, regulatory risk, and the limits of what these models can responsibly handle.
It also underscores the need for serious collaboration between AI developers and mental health experts. As LLMs move deeper into daily life, the edge cases aren't just technical, they're human. That's a lesson the AI world can't afford to ignore.
Switching gears, there's a potentially seismic development on the OpenAI side as well. According to CoinDesk, the Financial Times is reporting that OpenAI has discussed offering the U.S. government a 5% stake in the company. This would represent a new tier of government involvement with a major AI lab, potentially giving Washington a direct say in OpenAI's governance.
If this goes through, it's a sea change. The U.S. government wouldn't just be regulating AI, it would have skin in the game. That could help with alignment on national security, safety standards, and export policy. But it also raises tough questions about independence, research freedom, and global market access. Every rival, from Anthropic to Meta, will be watching. If OpenAI gets state money and oversight, did they get the same? Does this start a global race for government stakes in AI labs?
And from OpenAI's perspective, it's a hedge. By giving the government a seat at the table, they might preempt more hostile regulation or win privileged access to government contracts and data. But it's a double-edged sword because political winds change fast, and what's an advantage today could become a huge constraint tomorrow.
Exactly. If Washington wants a say in everything from safety settings to international deployments, OpenAI's agility and global ambitions could take a hit. It's a new era for governance in the AI sector, and the ripple effects could be felt worldwide.
Let's dive into the research beat, starting with a new architecture for self-evolving agents. A paper just published on Archive introduces C, that's self-evolving agents with anytime valid certificates. The big idea? Agents that can self-modify, but every change is strictly gated, logged, and auditable with error budgets and multiple verifier-in-the-loop controllers. On strong base models, this approach gave a 4 to 5 point jump on SWE bench verified, and the logs confirm the system actually blocks regressions in real time.
This is a big leap for agent reliability. Everyone wants agents that can adapt on the fly, but the nightmare is silent regressions. Your LLM suddenly forgets how to solve a task, or worse, picks up a bug and no one notices until it's too late. Having a system that logs every single self-edit and then gates it with both automated and human-in-the-loop checks is a milestone for compliance and trust. It's like version control for AI brains.
Exactly. And the fact that all modifications are restricted to a steering adapter while the core model stays frozen means you can audit and roll back changes without risking model drift. For high-stakes domains like finance, health, or autonomous systems, this could be the difference between responsible deployment and Wild West chaos.
And it sets the stage for a future where agentic systems can self-improve safely, with every change logged, traceable, and reversible. If this becomes standard, it could solve one of the thorniest problems in scaling agentic AI.
From agent evolution to memory, another new paper, AutoMem, reframes memory management as a learnable skill for LLM agents. Instead of hard-coding memory routines, the agent itself learns how to decide what to remember, when to retrieve, and how to organize its knowledge files. Using 2 automated loops, a strong LLM reviewing agent trajectories, and reinforcement from the agent's own best memory moves, the approach doubled or even quadrupled base agent performance on long-horizon games, making a 32 billion open model competitive with Claude Opus 4.5 and Gemini 3.1 Pro thinking.
This is genius. Meta-memory, knowing how to manage memory, is what separates human experts from novices, and now we're seeing agents learn the same thing. Instead of brittle, human-crafted memory hacks, the agent adapts its own memory strategy over thousands of steps. That's a game changer for anything long horizon, from scientific research to complex real-world automation.
And the 2-loop approach is clever. One loop optimizes the structure of memory, the other hones the agent's skill at using it. So you get both smarter scaffolding and sharper decision-making. This could be a high-leverage target for labs racing to build more general, robust agents.
It's also a reminder that a lot of agent progress won't come from bigger models, but smarter use of the memory they already have. That's a much more scalable path to real-world performance.
Let's keep the research train rolling. Another new archive paper tackles a core thorn in agentic pipelines, uncertainty estimation. The team presents a Bayesian framework for propagating uncertainty signals through multi-stage RAG, or Retrieval Augmented Generation, systems. By tracking uncertainty from planner, evaluator, and generator stages and pushing it through a Bayesian network, they can flag likely failure points and calibrate selective prediction. The system outperformed baselines on Hotpot QA, though it still hit limits on strategy QA.
Uncertainty is the elephant in the room for agentic pipelines. In practice, most LLM-powered RAG systems have no idea when they're about to fail, and in high-stakes settings, that's a non-starter. Pushing Bayesian uncertainty all the way through the pipeline is a major step towards making these systems genuinely trustworthy, especially in domains like maintenance, law, or government workflows.
And the node-level breakdown is key. It's not just a vague confidence score at the end, but a map of where and why the system thinks it might be wrong. That's the kind of transparency enterprise and public sector buyers will demand as agentic systems move into production. It's early days, but this is the shape of things to come.
Right, and the next challenge is scaling this kind of uncertainty propagation to even more complex pipelines while keeping the signal accurate and actionable. But if they can nail it, it's a powerful tool for catching silent failures before they impact real users.
Final research highlight, Grace RAG, a new architecture for closed-domain institutional question answering. Instead of relying solely on vector retrieval, it uses a governed graph-augmented layer to pre-resolve ambiguity, letting even mid-scale, self-hosted models outperform larger proprietary systems in quality and depth. The gains, up to 20% improvement, come from structuring retrieval, not just scaling the model.
This is a great reminder that retrieval architecture can be as important as the language model itself, especially in settings where accuracy, provenance, and regulatory compliance are non-negotiable. By structuring the retrieval step, you offload a lot of complexity from the model and make the whole pipeline more transparent and efficient. That's a very attractive proposition for institutions that can't or won't hand sensitive data to a cloud LLM.
And it shows that clever engineering can let even mid-scale open models compete with the giants, at least for well-scoped, closed-domain tasks. If Grace RAG's results hold up in production, expect a wave of interest from sectors like law, finance, and government, where cost and control are as critical as accuracy.
For sure, it's a reminder that AI progress isn't just about bigger models, but smarter pipelines, safer architectures, and tailored solutions for different risk profiles. As the enterprise AI landscape matures, these kinds of innovations will decide who wins the next adoption wave.
And that's all for today's main stories. We've got more robotics, hardware, and some wild research coming up after the break. Don't go anywhere. Before we close things out, a few quick signals from beyond today's headlines. Now let's shift gears to robotics. Tesla says its Model S and Model X production line is now helping build Optimus robots, which is a neat loop if you think about it, the car factory becoming a robot factory. Jamie, that sounds like classic Tesla, but also like a serious manufacturing signal.
It does. The key question is whether this is just a clever rebranding of human-assisted assembly or whether they're actually using the line to mature robot workflows in a real production environment.
Exactly. And if the Optimus is getting built inside a high-throughput automotive system, that means the robots are being tested against the hardest kind of benchmark there is: repetition, precision, and zero patience for mistakes. That is where robotics either gets practical or gets exposed.
Also, if the factory becomes the training ground, then the robot isn't just a product anymore. It's part of the factory's own operating model.
Right, and that makes this more than a headline about one robot. It is a glimpse at how embodied AI may actually scale, not through one-off demos, but by quietly becoming infrastructure.
That distinction is important. A lot of medical AI is good at pattern matching, but diagnosis is really about stitching together imperfect signals into a defensible path forward.
Exactly, and the paper's framing suggests it is trying to go beyond human annotation limits, which is interesting because rare disease cases often outstrip any neat labeled dataset. If it works, it could help clinicians think wider without forcing them to manually search wider.
The big test, though, is trust. In medicine, it's not enough to be impressive. The system has to show its work in a way a clinician can audit.
And that is the real story here, not just whether AI can guess the diagnosis, but whether it can support a reasoning chain that feels clinically useful, cautious, and reviewable. On the hardware side, actually not a chip story this time, but it does feel like the workplace agent equivalent of a hardware throughput upgrade. Workbench Revisited says the best agent has gone from 43% task completion in 2024 to 98% in 2026, with unintended harmful actions dropping from 26% to 1.9%. Jamie, those are the kind of numbers that make executives sit up.
They do, because this is where AI stops being a toy and starts looking like infrastructure. If the failure modes are falling that fast, you can imagine real deployment conversations getting a lot more serious.
And the safety angle is the surprise. Usually, people assume more capability means more risk, but here the benchmark suggests the opposite can happen inside a good task environment. Models that finish more also break things less.
That's encouraging, but it also means the bottleneck may move from model quality to workflow design. The question becomes, what tasks do you hand over and what guardrails sit around them?
Exactly. The agent may be nearly there, but the organization still has to be ready for it. There's also this nice little gameplay paper about coachable agents, systems that can be steered in real time to play with different styles rather than one locked-in strategy.
So basically, the AI version of, can you try it my way but still win?
Exactly. It's a tiny reminder that not every agent needs to be a ruthless optimizer. Sometimes the fun is in making them adaptable, teachable, and a little more like a partner.
That is a much friendlier vibe to leave hanging in the air. Across today's stories, a few things stand out. Frontier models like Claude Sonnet 5 are finally getting the regulatory and technical green lights needed for enterprise scale, while OpenAI faces growing scrutiny from the courts and potentially the US government itself. On the research side, breakthroughs in agent self-evolution, memory, and uncertainty point to a future where agentic AI is safer, smarter, and more auditable. The industry's moving fast, but the big questions about trust, governance, and real-world reliability are only getting sharper. Expect the competitive landscape and the policy debates to heat up from here.
We'll be back tomorrow with more frontline coverage and analysis. For now, thanks for listening to Midnight Signal AI. Stay sharp, the future doesn't wait.